Okay, welcome back to Miss Sussman's class. As always, please make sure that you have pencil and paper to take notes. You're also going to need your math binder, and you're going to need to open up your math binder to lesson 2. You'll see why in just a second. But make sure you have your math binder, pencil, and paper to take notes. Okay, our essential question is, how can you tell if a number is prime or composite? Well, obviously you need to know what a prime number is and what a composite number is. So let's define them. A prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. And let me give you an example. The number 13 is a prime number. Are there any other numbers that you can multiply together that will equal 13 besides 13 and 1? Think about it. Does 2 times 13? 2 times anything equal 13? Does 3 times anything equal 13? Does 4 times anything equal 13? The answer is no. The only 2 factors of 13 are 1 and 13. That's what makes it a prime number. It's a whole number greater than 1 that has exactly 2 factors, 1 and itself. In other words, the only 2 numbers that you can multiply together to equal the prime number are 1 and that number. Another example would be 7. Can you think of any 2 numbers besides 1 and 7 that you can multiply together that will equal 7? 2 times anything equals 7? Nope. 3 times anything equals 7? Nope. You get the idea. A composite number is a whole number greater than 1 that has more than 2 factors. An example of this would be 12. Let's think of the factors of 12. Take a second and write them down, and then see if your answer matches mine. Okay, you should have gotten 1 and 12, right? And then what else can you multiply? 2 and 6 and 3 and 4. And you can use divisibility rules, can't you, to find the factors. 12 is divisible by 2 because it's even. It's divisible by 6. It's divisible by 3. It's divisible by 4. Is it divisible by 5? Nope. And is it divisible by 9? Nope. So you can kind of use divisibility rules to help you. Sometimes you'll need more than just divisibility rules depending on the size of the number, but it will help you. Another example of a composite number would be 8, because 1 and 8 are factors of 8, because 1 times 8 is 8, and then 2 and 4. 2 times 4 also equals 8. So a composite number is a number that has more than 2 factors. A prime number only has 2 factors, 1 and itself. Okay, get your math binders out, because we are going to use them to help us find all the prime numbers under 100. Okay, you need to be in lesson 2, chapter 6 of your math binder. Excuse me, and I believe the second page of your math binder has this chart on it. Okay, and we're going to use this chart to find out all of the prime numbers that are under 100, and I'll show you how. We're going to kind of do it together. So I will do it on the computer, and you are obviously going to do it in your book. And you need to do this because you need these notes. Okay, so the first thing I'm going to do is I am going to cross off every even number after 2. Leave 2 alone, okay, because 2 only has 2 factors. But every other even number I'm going to cross off like this. 6, 8, 10, 12, 14, 16, 18, 20, 24. I'm not going to keep naming the numbers. You get the idea. You need to be doing this as well in your book. I'm going to finish crossing them off and then get back to you. Okay, you should have something that looks like this. Hopefully, you paused it as well and crossed all these off. Why would I cross off every other even number besides 2? I want you to think about that for a second. If you said because all of the other numbers, even numbers, can also have a factor of 2, that's correct. For example, 4, the factors of 4 would be 1 and 4 and 2, because it's 2 times 2. With 6, it's 1 and 6 and 2 and 3. You get the idea? So every other even number we can cross off. It cannot be prime because all those other even numbers have a factor of 2. So they have more than 2 factors, therefore they cannot be prime. Okay, the next step is you're going to look at the 3's and you're going to skip 3. So you're not going to cross this one off, but you're going to cross off every other multiple of 3. And I'll start. So 3, we've already crossed off 6. The next one is 9. The next one is 12, which we've already done. The next one is 15. You get the idea. What I would like for you to do is pause this, cross off all the other multiples of 3. And if you, obviously you're not going to know the multiples of 3 past like 36 because that's 3 times 12. Just keep counting by 3's. For example, I was at 15, so I'm just going to count 1, 2, 3 and cross it off. It's already crossed off for me. Woohoo! So I'm going to count up by 3. 1, 2, 3. This one's not crossed off, so I need to cross it off. So you can just count 1, 2, 3. This one's crossed off. Okay, so pause it. Keep counting up. Start with 24. Count up by 3's. And then check your chart with mine. Okay? Unpause it and check your chart with mine. Here we go. Okay. Your board should look like this. And I should have done it in another color. I apologize. I'll do the next one in another color so that way you can see what's filled in. But just go through line by line and check to see if you've crossed off all the ones that needed to be crossed off. Okay, and can you guess what we're going to do next? Oh, you're so right. We are going to do the 4's, and I'll do the 4's in red for you. So 4 is already crossed out, so now I'm going to skip count by 4's. 5, 6, 7, 8 already crossed out. 9, 10, 11, 12 already crossed out. 13, 14, 15, 16, already, you get the idea. But you want to keep doing it all the way through. 20 is crossed out. 24, 28, 32 is crossed out. 36, 40, 44, 48, 52, 56, 60, 64, 68. Guess we're doing this one together. 72, 76, 80's crossed out. 84. Yeah, these are all going to be crossed out because they're even. 88. I'm still going to check them. 92, 96, and 100. So they're already crossed out. There's nothing to cross out for the 4's. Let's check the 5's. This one's easy, right? 5, 10, 15, 20, 25. I need to cross that one out. 30, 35, need to cross that one out. 40, 45, 50, 55, need to cross that one out. 60, 65, 70, 75, 80, 85, 90, 95, 100. And then we need to do, we did the 5's, we need to do the 6's. Okay, so we're going to it's 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72. Now, I'm not sure, so I'm going to, after this, because that's 6 times 12 is 72. So now I'm going to count by 6's. 1, 2, 3, 4, 5, 6. Already crossed out. 1, 2, 3, 4, 5, 6. Already crossed out. 1, 2, 3, 4, 5, 6. Already crossed out. 1, 2, 3, 4, 5, 6. Done. 1, 2, there's, okay, so we're done. Now we're going to do the sevens. I know this is taking forever. Don't worry, this isn't going to be the longest video in existence. So we're going to skip count by sevens. We've got 7, 14, 21. Now you notice I'm doing this pretty fast, aren't I? 28. That's because I know my math facts. 35, 42, 49. Ah, that one needs to be crossed off. Let's pick a different color. Let's do green. So 49 needs to be crossed off. 56, 63, 70, 77 needs to be crossed off. 84 is already crossed off. Now from here I don't know, so I'm going to just count by sevens. 1, 2, 3, 4, 5, 6, 7. That one needs to be crossed off. 1, 2, 3, 4, 5, 6, 7. Already crossed off. And we're done. Okay. And let's do the 8s. Real quick, we've got 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96, and we're done. Let's do the 9s. 9, 18, 27, haha, got you. 36, 45, 54, what's that, 9 times 6? 9 times 7 is 63. 9 times 8 is 72. 9 times 9 is 81. 9 times 10 is 90. And we've got 99, so we're good. And then your 10s are already done. Let's try 11. There's 11. 22, 33, 44, 55, 66. Yeah, those are all done too. 12, 24. You should already be done, but we'll check them anyways. 36. 12 times 4 is 48. 12 times 5 is 60. 12 times 6. I can tell I don't do the 12s very much, huh? Is 72. 12 times 7 is 84. 12 times 8 is 96, and we're good. And then the last one I think we need to do is the 13s. I don't think we have to go past 13. 13, and this one obviously you're not going to know, so you can count up by 26. And I'm going to do that real quick because I'm running out of time. So I'm going to do it, and then you do it, and we'll see what happens. Okay, I circled all the prime numbers. You want to write them down in your chart. We don't have a lot of time left, so I'm moving on to the next slide. Okay, I want you to think about how you can use divisibility rule to help you determine if the number 117 is prime or composite. Pause it, think about it. We'll meet back in a few seconds. Okay, really quickly because we're running out of time. What you would do is you would go through the divisibility rules and you would realize that 1 plus 1 plus 7 equals 9, which means it's divisible by 9. And so it couldn't be a composite or a prime number. It has to be composite because it has more than one factor. Okay, it's also divisible by 9. Okay, your homework tonight is to determine if 282 and 109 are prime or composite. You want to use your divisibility rules to help you. All right, good luck.